Hey guys, yeah, so we're going to do an introduction to economics, and we talked about the central economic problem is about scarcity, right? Where you have wants that are unlimited, and but you have resources that are limited. Then to produce these limited resources, you need to have production. And production has factors. So the factors of production are land, labor, capital, which includes tools, and entrepreneurship. Okay? So and we also talk about the production PPC, which is the production possibility curve. Okay, so what is a production possibility curve? For example, if you want to produce cars or bananas, right, you can only produce one of these two goods. Then if you were to focus only on bananas, you can make 700 bananas, but no cars. So you put all your resources to producing bananas, right? Then if you wanted to, say, switch and move some resources to make 100 cars, then the number of bananas you forgo would be 40, and you can only produce 660. So the difference is this minus this. Okay, so I'm just going to move this here. So this will be DC for cars, change in cars, and D bananas, which is change in bananas. Okay, so to forgo 100 cars, you would have 40 bananas. Okay, then we add another 100, so we want 200 cars. We can only get 600 bananas. So I copy these two formulas down, and let's see what we get. Copy, paste. Okay, so now we have to forego, to make another 100 cars. Oh, sorry. This one should be equal to this minus this, right? So you get 100 cars, you have to do equals to this minus this. You have to lose 40 bananas. Okay, so I copy and paste, right? So to add another 100 cars, you have to lose 60 bananas. Then if you add another 100 cars to 300, we get 500 bananas. So I copy paste the formulas. Now to get another 100 cars, you have to lose 100 bananas. Okay, then to make 400 cars, we have to move some resources away from banana producing, so we can now only make 300, right? So what happens here is to make another 100 cars, now you have to, right? So next we want to increase cars from 400 to 500. Then we have to forego all the bananas 300, right? So this here shows you. So these are the points on the production possibility curve in green. Then we are going to plot this on X and Y axis. So I insert a chart. There we go. We have this. Oh, bananas. Wonderful. Right. So we have this nice curve here. I'm gonna add the axis titles. Right. So I'm gonna rename this as production possibility curve, which is PPC. And I'm gonna name here on the x-axis we have bananas. On the y-axis we have bananas, and on the x-axis we have cars. Okay, so you can see that right. Now make it bigger. Make everything bigger. Oops. Right, bigger is better. Bold and bigger so you can see, and the numbers as well. 15. Okay, bold. Right, so this is the production possibility curve. Right, so what you see here is the change in change in cars, right, divided by change in bananas. Okay, this is like your dx and this is your dy. So your gradient is your dy over dx, which is equals to d bananas over the cars. Oh, there you go, and it did everything here. So equals to this divided by this. Okay, so you have your gradient getting more and more negative as you move to the right. So yeah, you can see here. So the gradient at this point, right, at the 10660 point, which is this one, has this gradient negative 0.4. So I'm just going to insert some shapes and draw that this guy is the gradient at this point, right? And what is that represented by? That's represented by a triangle, right? So let's see, -1. What about minus? Okay, let's go to -2. -2. The -2 gradient here is the point at 400, right? 400, right? So how do we get this gradient? We did the difference between the rise and the run, which is the slope, right? So if I were to insert a shape like a right angle triangle, is there like some kind of right angle triangle? Let me see. Oh, this triangle is not right angle though. Can I turn it? Okay, yes, I can turn it. Very good. Oh, 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 okay. Whoa, how can I make this triangle be more like, for example, this guy here, that is the triangle. Okay, from this point to this point, right? This is the gradient of -2. Okay, because now if I just remove the fill, no fill, no fill. Yeah, and the outline I just make it red so you can see. Right, basically this triangle is the change in Right, you get the idea anyway. So if I insert like an arrow here from 500 down to no, from where? From, oh, sorry. This one is the right. This triangle here refers to uh oh, bro. I'm pointing at the -1. The -1, okay? This one, because it looks like a 45-degree triangle, right? That's the change going from 300 to 400, right? Right? 300 to 400, and you're going from 500 to 300 down bananas, right? Okay, so this is the bananas. 500 to 300 means you're going from here to here, okay? Right? That's where you lost 200. So I box it, yeah? And then we increase by going to the right. The 300 to 400 cars, okay? Then I box it here, right? So this, if I just try to insert, yeah, okay, so you get the idea. That is the slope. The slope here is oh, it's -2. It's -2. Yeah, it's -2 actually. That's correct. That's correct. I was looking at the correct one. So this one has a slope of -2. Okay, so I insert a text box. I don't know, insert like a rectangle here. Okay, I just say gradient equals -2. Okay, so the gradient is -2. That's the red triangle. Okay, that's the change going from 300 to 400 cars and foregoing 200 bananas by going from 500 to 300. Okay, so the question here is, why is the curve concave outwards? Okay, why is it concave outward? Why is it bent outwards? Why is it not a straight? Why is it not a straight line going from from 700 all the way to 500? Why is it not this guy? Yeah, yeah. Why is it not this orange line? Because, okay, or why is it not the other way? Because, okay, so it is concave outwards because of the factors of production, okay, being non-homogeneous. What does non-homogeneous mean? So non-homogeneous is, for example, we talk about land. You got different types of land. You have fertile land for bananas, and then you have I don't know, like maybe a building with car producing machines already there or something like that, right? So the fact that these two things are different means they are non-homogeneous. Yeah, these two things are non-homogeneous. So I merge. Okay, these are non-homogeneous. Okay, this is one thing, one example. Okay, then labor, like the kind of people you have, banana farmers working for you. They are experts in, and then you have car engineers working for you. Okay, so you have different types of people working for you, and that is non-homogeneous. So imagine if you were to move, to make another 100 cars. Say you have, first you start, maybe you have like 50 banana farmers and 50 car engineers, right? And you put them, all of them, to make bananas. Then, as you want to make 100 cars, first you will use up maybe 10. uh, okay, so for example, if I put here the the banana farmer here, and I put the car engineer here, car engineer here. Okay, you start with okay, the car engineer for cars, and then for bananas. Okay, and cars and bananas. Okay, so banana farmer can be put to make cars. Car engineer can be put to make, so you have 50 car engineers, and you have also 50 banana farmers, for example. Then here you are making, for example, you're making 700 bananas. So you put all your guys, which is your 50 car engineers, to make bananas, and your 50 banana farmers also to make bananas. Okay. Then later on, you want to make 100, for example, 100 cars. So I'm going to start using obviously my car engineer first, right? So I'm going to send 10 car engineers to make cars, leaving only 40 to make bananas, and the other 50 are still doing. So what happens is, okay, so I I lost, because they are car engineers, right? They're not actually very good at making bananas, so I only lose 40 bananas. Okay, then I'm going to move 1, 2, 3, 4, 5. Okay, yeah, then I'm going to move another 10. Okay, another 10, so I get 20. To make another 100 cars, I move another 10 car engineers. Okay, then I get 20, okay, left 30. Okay, and still 50 here. Or maybe I should do like, yeah, okay, but that's the idea. Now, uh, maybe some of the best car engineers, right? The next 10 are maybe not so good car engineers. So maybe we need to add more, maybe like 25, for example. So you add 15, you take away 15 here, I get 25 left, right? So you see, as I have to move more of the less skilled car engineers, uh, I have to move, lose 25 people, and those 25 car engineers, could have made like 60 bananas. So now we lose that 60 bananas. Okay, then we continue to add, like maybe, to make the next 100. Now I have to maybe add 17. So 25 plus 17 is what, 40? I don't know. Or maybe I just keep it simple. Let's just put 20 here and 30 here, then 30 here, and then 20. Actually, no. Oh, actually, no, no, no. Sorry. Everybody is okay. Everybody. So I have to move. Uh, Everybody's making bananas. So I'm gonna shift 20, 20. Yeah. Okay, okay. So I have to actually start by shifting 20, then 30, then another 20 workers here. Then I'm left with 10 here. Then I hit 50 here, add another 20. This is already 0. But, right, and then this one is, I have to, no, cars 50 and then 10 here. And this one is 40. Yeah. So basically, and this one will be at another 20 here for cars. All right. So I have now 50, 50. Then I have 30 and 50 and 0. This one lose 20 here and 0. So the idea is if we just fill in the okay, let's put in the bars here. So if I insert the how do right, home data bars, right, you can kind of see that we are shifting people who are car engineers from making bananas over to making cars, right? Which is what's happening here, right? So why does the number of bananas drop more and more? Because at first we have, the as you move down the curve, the people that you're transferring over are the more skilled banana farmers. You transfer them over to making cars. So they are more specialized in making bananas. So you're gonna need more of, and they're not so specialized in making cars. So you need more of them. So the price of the opportunity cost is increasing, right? So because of non-homogeneous factors of production, this causes increasing opportunity costs, right? When reallocating labor, for example, yeah. And the same thing goes for tools and entrepreneurship as well, because you have, different tools like for example, you have you have you have banana, I don't know, clippers to clip the bananas from the tree, right? And then you have car producing robots, for example, right? So these are different tools and they are non-homogeneous, okay? Then you have entrepreneurship where you have like, businessmen with, maybe MBA degree, or you can hire, uh, I don't know, like uh, uh, engineers, the human capital, the people who put it, they have different skills basically. So it's non-homogeneous. So the whole idea is that when you're trading it off, it gets more and more costly, right? As we that's why the slope increases. As you move from the left side of the curve to the right side. Okay. Right, it's because of non-homogeneous factors of production. So that's it for the introduction to economics. Thank you.